Jim, do you think we ought to explain why we have a chapter 1 called Research Methods, and this is supposed to be a statistics book?
Good point. Essentially, some people suggest that you should learn statistics and then research methods. Other people suggest you should learn research methods and then statistics.
Yes, because knowing a lot about research methods gives you a head start on learning statistics, but knowing a lot about statistics also gives you a lot of information about research methods.
So while we're going to talk about statistics throughout our text, we're going to give a brief introduction to research methods,
where we're going to talk about the aspects of research methods that are directly related to statistics. There's a lot of things about research methods that we won't talk about. For example, how do you find a problem? How do you disseminate the results? Those are part of research methods, but they're not connected to statistics.
So, what's the purpose of research? Well, the purpose of research is to learn the truth about something. Generally, you're interested in the truth about the relationship between two variables, an X and a Y. What's the relationship between cigarette smoking and lung cancer?
Or between physical activity and health benefits.
How do you know something's true? Well, there's a variety of ways in which you can determine that.
Or at least there's a lot of ways that you think you learned about what's true and what's not true. Here's a few of them.
Importantly, we want to focus on the last one, and that is, I read a research article. So what we want to do in this textbook is to help you make a decision based upon research.
And in order to do that, research is going to have to use statistics. So we're going to have a statistics book, but we have to learn about how we do research to start.
And we want to know the truth about the relationship between an X variable and a Y variable. If I manipulate smoking, what happens to your lung cancer risk? There are many issues that come into play when you conduct research. Those issues will be discussed throughout the textbook, but here's a couple of examples.
How do you measure variables? What level of measurement is available to you? How do you select subjects?
If there's a treatment, how long should the participants be involved in the treatment?
Right.
And so forth. So there are many different kinds of issues that come into play. But importantly, the heart of the research procedure is you want to learn the truth about the relationship between X and Y variables. And that's what research methodology is all about. Whenever you're looking at those variables, X and Y, they have specific names.
One of them is called the dependent variable, and that variable is the one that you expect to change as you manipulate the
independent variable. So, for example, is there a relationship between skin fold measures and hydrostatically determined body composition? Yes, there is. So as X changes, is there a concurrent change in Y? There's a relationship there.
Or, for example, what's the relationship between physical activity and health benefits?
Well, there are a variety of sources where you might come up with these research hypotheses. For example, it might just be a wild guess. It's something you have interest in.
You might have read a theory and you'd like to test to see if the variables react as the theory suggests they would.
You might have looked at previous research and had some examples based upon what you saw in the past you'd like to confirm.
Maybe something happened to you and you had something occur in your experience and you'd like to test it to see if it is actually true.
And then it might just be some logical relationship that you think exists. Logic plays a big role in what we'll do throughout our text. So we have these research hypotheses. Well, what do they actually look like? We have two types. The first is the research hypothesis.
The research hypothesis is the one that you are going to propose as what's going to happen to variable Y when you manipulate variable X.
I think if you engage in more physical activity, your blood pressure will be normal. Alternatively, there is the null hypothesis, and this is the hypothesis that's actually tested with statistics. The null hypothesis says there is no relationship between X and Y. That's to say, there is no relationship between physical activity and your blood pressure. It's the null hypothesis that's actually tested statistically.
Now, there's many other issues that we are going to omit at this point, but we will cover these in later chapters in the text.
This refers to the types of tests, how confident you can be about your answer, which statistical procedure should you use, how many subjects should there be, and how are they assigned to groups, and so forth. So those are many things that you're going to yet see. But essentially, hypothesis testing in the research methodology gets at inference. What you're going to do is you want to gather data on a sample, and based upon that sample, you want to infer to a population. Maybe your sample consists of 600 people in a forthcoming election. And based upon those 600 people, you want to infer what the results would be in your state, or what the results might be nationally. Essentially, you gather data on a sample in order to infer with some degree of confidence what the population values will actually be.
Now, it isn't always as simple as Jim makes it sound, because there are many issues that are involved in such a process. For example, how do you define the population? How do you know if a subject belongs to the population or not? There are methods of selecting subjects, the number of subjects that you need to select. Can you eliminate confounding variables? Are you going to include a control group? And it goes on from here. Many things that we're going to have to learn about in order to conduct a research study.